Hey, all you wonderful geometry students out there. This is Mr. Hartz coming back to you after spring break. Hopefully, you guys were able to rest, relax, spend some good quality time with your family, and stay home. Today, we're looking at arc length. Okay, so we're going to stay with circles for a little bit here. And today, we're looking at figuring out how long an arc would be. So, if we think back and review just a second, if we have an arc on a circle, here's our circle. Arc on that circle, just a distance between 2 points on the circle that curves, right? So we just want to figure out how long is that arc, right? What is this length here? Okay. And I want you to think about, what do you think that arc length will relate to? Something that we already know about. Well, hopefully you can see that this arc is just a fraction of the circumference of the circle. So for example, if I wanted to figure this out, let's say I knew that there was a central angle here of theta degrees. I know that this arc length has to be a fraction of the whole circumference. Just as a reminder here, circumference equals 2 pi r. We've already talked about that in this class, and hopefully you knew it from grade school as well. But the circumference of a circle is 2 times pi times the radius, right? So we'd have to know this radius here, which works well with our central angle. Theta here is the central angle. And now if you think about it, what could be a formula then for the length of this arc? Well, what fraction do you think this is of the whole circle? Well, before I write that, I wanted to ask you one more thing. Let's think about an easy central angle. Well, think about this circle right here. Let's say that it has a radius of 5. What then would be the arc length right there? Well, again, think about, what would the circumference of that whole circle be on the top right there? Well, if we're following 2 pi r, then it'd be 2 times pi times 5, which would be 10 pi. But we know that the whole circle here has a circumference of 10 pi. What fraction of the circle do I have? Well, you might say, well, that looks like a fourth of it, right? So it'd be 10 pi over 4 would be that arc length. Okay, and the question is, how do we know that that is for sure a fourth of the circle? Well, we think about, again, how many degrees are in total in a circle. Well, there are 360 degrees in a circle. 90 here over 360, if you reduce that, 90 over 360 is 9 over 36, 1 over 4. So you'd be right, it would be a fourth of 10 pi inches, right? Or 5 pi over 2 inches. Okay, so we get the fraction that we multiply by the circumference by taking our central angle and dividing it by 360. So here comes our formula, right? Arc length equals theta over 360 times 2 pi r. Again, this 2 pi r here is simply the circumference. This theta over 360 is the fraction of the circle we have. Okay, so all we have to do is know the central angle and the radius, right? Or the diameter, because we know how radius and diameter relate to each other. And we can calculate this arc length. Okay, so let's try an example here. I'll call up my calculator for a second too. Let's try an example. Okay, so here's the problem. I want you to find the arc length. Okay, and just to be clear, since there are two arcs drawn here, on this particular arc length, right here. Okay, so to calculate that thing, I'm going to use my formula. I'm going to write my formula up here. And again, to remember that, as long as you remember circumference is 2 pi r, right? It's just the central angle over 360 times 2 pi r. So to figure out this arc length, then I'm just going to say arc length equals. That's what's unknown, right? My unknown is arc length equals theta, which I know is 60 degrees over 360, times 2 times pi times r. Okay. Now you can do this by hand or you can use a calculator. Okay. But I like to simplify things here first to make this a little bit easier. 60 over 360. Okay. Right away, I see they both end in a 0, so I can cancel out the zeros. One of each. And I know 6 over 36. 6 and 36 are both divisible by 6. So I get 1 over 6. And I know 2 times pi times 18. I know 2 times 18 is 36. Okay. And then multiplying these together, 1/6 of 36. 1/6 times 36 would be 36 over 6, which would equal 6. And I get an arc length of 6 pi. And again, if you think about this answer right here, this 36 pi, that was the whole circumference. But I know I only have 1/6 of that whole circumference. Okay, to show you how to do this on a calculator here, okay, I like to type in, this is kind of like what we did a standard like this before. I like to type in everything except for the pi. So I had 60 over 36, or sorry, 60 over 360. And again, it's times 2 times pi times 18. Notice I don't type the pi into my calculator because I want to leave my answer in terms of pi. Right, when I do that, I see that answer of 6. Now, 6 is not the answer. I have to remember to write the answer as 6 pi. Okay. Let's try another one. Okay, so I want to find this arc length here. Again, just to show you which arc I'm talking about. This one right here. And again, this one I'll do entirely on the calculator and kind of show you how that can help you here. Arc length equals then my theta over 360. My theta here is 100 over 360 times 2 times pi times the radius. Now you can do it by hand and start reducing this fraction here. Right? We can reduce that fraction and then multiply by 8 pi. Okay, or we can just do it all on the calculator and see what happens. So let's try this one on the calculator and then we can confirm it by doing it by hand. So we have 100 over 360 times 2 times pi times 4. But notice, I don't want to type the pi in because I want to leave my answer in terms of pi. And I get this 20 over 9. And sometimes you get fractions like this. Sometimes they come out nice, like 6 pi in problem 1. Sometimes they come out a little bit not as nice. But that's still our answer. So my answer would be 20 over 9 pi. And my unit would be inches. Remember, arc lengths always have linear units. And again, to think about this, right? This 100 over 360. That could also be, if you wanted to do it by hand, that can be 10 over 36. I know 10 and 36 both divide by 2, so I could call it 5 over 18. And then multiplying that by 8 pi. Right? This can become a 9, a 4. 5 times 4 is 20 over 9 pi. So I can do it by hand, or I can do it with a calculator. We just want to make sure we leave our answers in terms of pi, and we want to make sure that we have a simplified fraction out front. Okay, let's try one more example, and then we'll be done for today. Okay, so this problem doesn't have a picture associated with it, but you're always welcome to draw one. This one's also different because I am asking you to find the central angle, right? In the first two problems, we solved for arc length. Here, I'm asking you to solve for central angle. Okay, but it's using the same, right? We know this is an arc length problem because I can see arc length in here, right? So I'm still using that same formula. Arc length equals theta over 360 2 pi r. Now in this problem, I'm going to have to go through and plug in where the numbers are going, and I just have to do it carefully. So here's what I know. I know the radius is 10. So I know 10 is going to go in, right? This 10 is going to go in for r. And I know the arc length is 5 pi. So I'm going to plug in 5 pi for the arc length. Make sure you understand that 5 pi is part of that number, right? The pi needs to go in here as well. What's unknown then? The only thing I don't know is theta. And that's my central angle. That's what I'm trying to find. So let's see how we would do this. Again, 5 pi is going to go in for my arc length. I don't know theta, so it's going to stay theta. And 2 pi r is going to be 2 pi 10. Because I know r is equal to 10. Okay, simplifying this right here, I get 5 pi equals theta over 360 times 2 times 10 is 20. Okay. Now I just have to solve for theta. Okay, the first thing I'm going to do is I'm going to see that there is a pi on both sides of this equation. So I'm going to go ahead and cancel out the pi. I'm going to get 5 equals theta over 360 times 20. Okay. Then I'm going to divide both sides by 20. Five divided by 20, you can use your calculator, is 0.25. And then to get theta alone, I just have to multiply by 360. All right, and going back to my calculator, I can see I would do, all right, I would have done my 5 divided by 20 to get my 0.25. Then I'd multiply by 360. And I get theta to be 90 degrees. So I know my central angle is a right angle. Okay, that's it for today's video. Go ahead and work on these practice problems. Good luck. Talk to you guys later. Bye.